1, 2, 3, 4. Side, angle, side, 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 side. Angle, side, angle, 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 side.
Side, angle, side, 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 side. Angle, side, angle, 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 side. Side, 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 angle, side, angle, 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 side. Side, angle, side, 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 angle, side, angle, 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 side. Side, angle, side, 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 angle, side, angle, 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 side. Side, angle, side, 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 angle, side, angle, 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 side. Side, angle, side, 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 angle, side, angle, 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 side.
Hey there, geometry students, and welcome back. Here we are, 5.6, Big Ideas. Again, proving triangle congruence. So apparently triangle congruence is a huge thing over there in Korea with the side angle side song, side, 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 and all the hand motions and everything. So they really get into this. But here we go with two more triangle congruences. We got ASA and AAS triangle congruence theorem. So we're going to take a look at these and basically do the same things as we've done in the past, just now applying these two theorems to our repertoire of being able to prove triangle congruence. But before let's go on to a cartoon of the day. And here we are with two snowmen, probably a Sith Lord snowman and a Jedi snowman, and the Sith Lord says, "Come to the dark side, there's more shade." Obviously that makes more sense to the Jedi. Yeah, I don't want to melt. So here you go, little Star Wars snowman. Okay, so here we are with our first theorem, angle side angle, the ASA congruence theorem. So as we can see on our diagrams, we have two angles and a side that's included. So it's an included side this time. We've talked about SAS, where it was two sides and an included angle. This would be two angles and an included side. That's what it's saying here. Two angles included side of one triangle, or congruent to two angles and included side of the second triangle. That means that that's all you would need to show that those two triangles are congruent. So you have two angles and the side in between those two angles are congruent. That's all you would need to have a congruent statement for that. The next one is the angle side, so AA and S, AAS. So same kind of idea here. You have two angles again, but not the included angle. You can have another angle, one of these other two angles. So basically, really, if you have two angles and one side, you can pretty much always prove triangle congruence. If you have two angles and one side, because you could have the two angles here and the one side here, that would be the AAS, or you could have the congruent side on this side as well, and you can go AAS this way, or you could have the congruent side be in between and do an ASA congruence one. So just realize that the two angles, one side is always a combination that you can prove triangle congruence with. So this would be a non-included side, so you could have it with an included side or a non-included side. So two angles and a non-included side will work, as well as two angles and an included side as well. All right, so let's just go ahead and apply them to these three, and these are three just like pictures with some triangles in there. You don't need to write this down. We'll just look at this and watch this. It just says, can the triangles be proven congruent with the information that's given here in the diagram. So as you can see, we got these triangles here have some marks. There's an angle there that's congruent. There's a side here that's congruent. And we also can understand, because of the X right here, we have vertical angles going this way and this way. This is the direction, though, that we would want to see that these two angles here would be congruent. So it's an angle, and a side. So yes on that one. The vertical angles here show that it can be that congruent. So we can use angle, angle, side. It's a non-included side. We have two angles and one side, so it would be AAS for the non-included side. If this one was the congruent one, then the S would be in between the A's. On the kind of umbrella here, you have all three angles shown congruence. So that is not enough information. You need a side. You definitely need a side. You can't just show angle congruence with just all angles. Now we've learned in the last lesson we can have all side lengths, and that's fine. All S's, SSS will work, but AAA will not work. There's no triple A congruence theorem. There's a triple S, but there's no triple A. So just remember, roadside assistance. Triple A is not going to come along and help you with trying to prove triangle congruence. So this would be no, there's not an information. The one on the stairway here, you can see we got some angles here. So two angles right there are shown in the diagram. They're marked for us. And because we do have a shared side, that is a congruent side. So we do have two angles and one side here. So this works. Which one would it be, though? It would be the included side, because it's in between the two angles. So this would be the SAS on that one. All right, let's go on and try our extra practice. Okay, so here on page 151, exercises 1 through 4, decide whether there's enough information given to prove that the triangles are congruent. If so, state the theorem, and this theorem would be, in this case, most likely the two we're looking at, ASA or AAS. So I'm going to give you a chance. Let's just do 1 and 2. Just look at them. Go ahead and pause the video and write down if it's either yes or no, and if it's a yes, write down which one of the congruence theorems you're using to prove it. So go ahead and pause the video and then play it and see if you're correct. All right, let's go ahead and check your answers. For number 1, you do have the two angles and the one side, so definitely this is yes. But which one would it be? It's going to be AAS, because it's a non-included side. So you have your angles and then a side over here. The side in between the angles is not shown, so it's not the included side, it's a non-included. So AAS on that one. And for this one, we have the two angles and that we also have a side, so definitely yes. Which one is it, though? The side's in between the two angles, so this would be the ASA on this one, ASA for congruence theorem. So that's really all you needed to say there. Yes, AAS, and yes, ASA for number 2. Let's go on to 3 and 4. So go and do the same thing. Pause the video and do the same thing for 3 and 4, and then play it to see if you're correct. All right, so let's check number 3. So we're trying to prove that these two triangles are congruent. We definitely want to look at them here since they're kind of together. JKL is this guy over here. MLK is this guy over here. So we do have we have an angle, one angle, and then one side shown and marked on our diagram. But we also have, let's see some other things. What else do we have here? Well, we do have a side, so we actually can say a side right here. KL is congruent to KL, so that could, be a side. Would that work? Would that be enough with ASS? Well, that's a bad word even in math right there, ASS. We would not use an ASS. We wouldn't say yes because of ASS. Definitely that's a bad word in math as well. So this one we can see, though, there's an X right in our diagram. There we have a vertical angle situation. So right there, vertical angles means that these two are congruent. And so that would be an ASA on this one. So yes. See, I tricked you there. You thought it was going to be yes, just like I was saying, but why is it no? Why is this no? I just said these were vertical angles right here. Well, look at what I just discussed at the very beginning. What triangles are we really trying to prove congruent? That is these big ones here, not these triangles. Yeah, there's so many triangles in here, and you can get easily lost with the triangles. And so with J, N, K, right there, if that was what I was asked to show congruent, with J, N, K, and M, N, L, if that was it, then yes, I could say AAS, because then I could use the vertical angles right there. But the vertical angles here don't make any difference, because the ones I'm trying to prove congruent all go all the way down to here. Here's my angle right there that I would need to use with ASA, and there's no way to prove that this angle here is congruent to this angle over here. So because we can't use the side, then yes, there's a no. There's no other way. The only other thing we can see is congruent is this side, and that's not enough information. Like I said, ASS, can't use that one. So this one is a no, and you just got to make sure you are, when it's in the same thing, you're clear about which one it is. Number 4 here, they are separated, so it's a lot easier when they're separated than when they are kind of overlapping, like we saw in 3. So we have a right angle right there. Those are definitely congruent if it's a right angle. We have another angle, and we have a side. So 2 angles and a side. So definitely whenever you see 2 angles and a side given to you, you know for sure yes, and it's an AAS situation. Angle, angle, and then the non-included side. So that works there. All right, let's move on to our next part, 5 and 6. Okay, so on 5 and 6, it doesn't give us the diagrams. What it does give us is some given statements here. It says decide whether you can use the given information to prove that triangle LMN is congruent to triangle PQR. So what we'd want to do here is actually draw these triangles out, label them, and mark out what's shown to us, these congruent statements here, what's given to us on the diagrams that we're going to draw ourselves. So draw 2 triangles and label it LMN. Make sure you do corresponding labels with PQR. And then we want to mark off things that are congruent. So here's what eventually it should look like once you're finished. I just drew true, like kind of more equilateral triangles almost, but it doesn't have to be perfectly equilateral. Any triangle would work here. So I just drew them like that, and then I got for LMN, I start over here, LMN, and then I got the same thing, PQR, going the same direction. And then I just start marking off what's congruent. So it says angle M and angle Q are congruent. So M and Q, I put 1 mark there for those angles. And then these angles, N and R, are also congruent. I put the 2 marks for N and for R. And then NL, side NL, and side RP. So right here, NL and RP are congruent. So as long as we just have them, being congruent, so we have corresponding sides here, corresponding sides here, or I should say angles, corresponding sides. So you have 2 angles and a non-included side. So for that, yes, you can say that they are congruent because of the AAS with the non-included side there. So go ahead and do the same thing for 6. Now you saw me do that. Go ahead and draw your triangles. You could do the same 2 triangles, just mark off this information and see if it's a yes or no, and which congruence theorem you would use. So go ahead and pause the video and do number 6. All right, so 6 should be done now. You drew them, and it should look like something like this. You got your same 2 triangles there, but now the congruent marks may be a little different. L and R congruent, so these angles here. So L and R congruent. And then M and Q congruent. So we got M and Q up there congruent. And then we have LM, PQ. Those sides are congruent. So LM right here, PQ here. And as you can see on this one, you have an angle, side angle situation, but here you do not. You don't have the right angle, side angle. You have an angle, angle, side on this guy. So because of that fact, you're going to say no. L and R, they don't correspond. So that's what the whole point is. You have your L and R, they're not even corresponding in our diagram. L corresponds to P, or R corresponds to N. So if they would have had L and P, then we could have used AAS like this one. But if we would have had the N and R shown, then we could have used this one with the angle, angle side like that one. So no, because of L and R not corresponding. All right, here's our joke of the day. So we'll pause for a second to look at this. It says, I was wondering why the ball kept getting bigger and bigger. And then it hit me. That should make sense. Why it keeps getting bigger and bigger, and then whack. Flat on the ground. All right, so now we're going to get into our proofs. So we've seen proofs before using SSS, using HL. Now we're going to be using the angle, side, angle, 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 side to help us prove things. So in our given here, it does show us that we have some parallel lines with the marks there. They show parallel, and we also have a congruent side. What else could we use here to figure this out? Well, because of parallel lines, we can figure out angles. Alternate interior angles are congruent, so we could say that D and C are congruent. And also vertical angles can be congruent, so we can say these two angles here are congruent, and that would give us two angles and the included side. So that would help us use angle, side, angle. And so that's what they're going to show us here. They mark off first the given is parallel. And because of the fact that they're parallel, we can then say that D is congruent to C, like I said, with alternate interior. They then tell you that the given part of the side there, that's the given. So now you have your A, you have your S. And then we have our other A with the vertical angles, like I said. So there's your A, your S, and your A. S is included in this one. So now you just write off the proved part. The two triangles are congruent because of angle, side, angle. Okay, so here's one more proof. We'll take a look at this one. We have parallel lines, and we also have some right angles inside of here as well. And we're trying to prove that these two triangles are congruent. We can see them pretty clearly. We do have a shared side, and always shared sides are going to be congruent, so we can always use that and say reflexive property when we have that. And because of parallel, we can also be talking about alternate interior angles as well for that. So that's another thing we can be saying. And so if we do alternate interior angles here, that would be an angle, and then a non-included side, and that could use your AAS on that one. So they're going to talk about the parallel lines first, and then they'll talk about using the parallel lines to figure out an angle is congruent with alternate interior angles, like I was saying here. Alternate interior are going to be congruent. That's these two angles here. Or they could even use these two angles. It doesn't really matter which ones they use. They could do it either way. Would be fine. So they named it this way, GHF, GHF. So they did use this one, and then that means they're going to use this one up here. So this one and then this one here with HGK, HGK. So they chose to do it that way. We could have also chose to do it this way, FGH, and used this angle, and KHG and used that angle, and been able to do it the same, proving it the same way as well. Then they're going to say, okay, we got right angles, so that's a given, and so because we have right angles, those are congruent, of course. So that's why we can say that those two angles are congruent. So we definitely want to not just say that, or we need to definitely establish that those two angles are congruent, and that's the right angle congruence theorem, that all right angles are congruent to each other. It's not necessarily the definition of a right triangle, but it is a definition maybe of right angles, that all right angles are congruent. So that's why we'd want to say right angles congruence for that. All right angles are congruent. The other side, like I said, is reflexive property because it's equal to itself. And then we can just use our prove the two triangles are congruent because of the AAS. And then you're done. Okay, so problem number 7, here's our proof that we're going to be putting down. So we have this diagram over here in the given part. Always the given is going to be our first statement. In fact, you can put that down for number 1, that side AC, this segment here, or segment AC, bisects these two angles, DAB. So DAB is this angle up here. This one's being bisected right here, and also the angle DCB down here, DCB. This one is also bisected as well, so it goes right through the middle of that angle. So it goes right through the middle of this angle, through the middle of that angle. So just because of that fact, we do know that these two angles are going to be congruent because it cuts it in half. Bisecting means it cuts it into two equal halves. So we know right there that these two are congruent. We also know that these two angles here are going to be congruent because this is being cut in half as well. So those two are congruent over here. We also see from even just the diagram, we are going to have a shared side right here. Shared side is congruent always to itself with a reflexive property. So just maybe marking the diagram off so we can actually see, okay, well, I can use angle, side, angle on this one. So eventually when we get down to the very end, we'll be using angle, side angle at the bottom. So now we just kind of start to build this down. So the first thing you can be talking about is these angles here that are congruent off of your given. So we could say that angle CAB is congruent to CAD. That's the one right up here. So we have CAB and CAD. That's these two guys right up there. And that's because of the definition of angle bisector. So whenever you're going to bisect an angle or even a side, that really is a definition of a segment bisector or angle bisector, depending on which one you're bisecting. And then next one down here, you can do the same thing with these angles. And actually, I should say there's your angle. There's one angle, A. And over here, here's another angle. Right there, ACB, ACD. That's these guys down in here. That's these two here. Then we have to name them with the three angles. You can't just name it angle C or angle A up here is two things. You have to use the three letters to be able to show what you're actually talking about. And again, same reason, definition of angle bisector. And then number 4 would be that side right here. So AC is going to be congruent to AC. Okay, that's a shared side. It's congruent to itself, and that's because of reflexive. So a reflexive property of congruence is that one. And then always our last one is going to be our proof part. Now that we have A, and an S, it's not going to be AAS though, remember, because we have to actually say this. When we actually put our proof down here, we're not going to put AAS, we're going to put ASA, because the side's in between the angles, so it's an included side. ASA congruence theorem on that one. Okay, so here's our last one, number 8. So we have a circle in here. So in the given, it says that O is the center of the circle, and angle N is congruent to angle P. So that's what you'd first write down your statements and reasons. So statements here, you could start by just stating the fact that O is the center of the circle. That's a given. So we're not going to talk about N is congruent to P yet, but we can definitely say that this here is a given. I mean, if you put down N is congruent to P in the given part number 1, that's not necessarily going to be wrong, but that's not how they're showing it here. And we're trying to make a logical argument to be able to say that this triangle is congruent to this triangle. So we're talking about these two triangles in here. So if that's true, if O is the center, and then we have any line going from the center to the edge of the circle, is always going to be exactly the same distance. So these are all radiuses. A radius is from the center to the edge of the circle. These are all going to be R, or the radius, which means they're all going to be exactly the same. We know that those are all going to be congruent. And so now if these are congruent on this triangle, we have two sides congruent here, two sides congruent here. That makes an isosceles triangle with this. And remember, from isosceles triangle, the base angles are always going to be congruent. So these two are going to be congruent. So this is congruent to this, N is congruent to M, and P is congruent to Q. And so since N and P are congruent, these are all congruent. M is congruent. All these angles, all 4 of these angles then can be congruent to each other. So I can just put 1 marks here. I don't need to put a separate mark because they're congruent to each other, they're congruent to each other, and since it's the 1 mark, they're all congruent to each other, all 4 of those angles. So for number 2, we're going to talk about on this one, the sides. So we'll talk about these sides here because of the center. So that's what I was just saying. All the sides here are congruent. ON, OM, OQ, and OP are all congruent because all points on a circle are the same distance from the center. That's really just the kind of a definition, or just what we know from a circle, that all the points of a circle, it's kind of the definition of a circle, that all the points are going to be equal distance to the center point. So that shows you all those sides right there. So there's definitely an S. We even have a couple S's really in here. If we needed 2 S's, we could have 2 S's, but we're just going to use 1. And then for the other angles here, we know that all 4 of these angles are congruent because of base angles theorem. So that's where you have N and P are congruent. So you don't need to actually put that in the given. If you had put it, then you just wrote it twice there, and that's fine. But you just really need to say that all 4 of these angles here are congruent at some point. So you now have angle here and also angle here. So we have 2 angles now with M and N. Well, basically all of them are congruent. So M and P are going to be congruent, or these guys, or I should say maybe N and P, and then M and Q are congruent. And so there's your 2 angles. and we would have a non-included side. So now we can say the two triangles are congruent because we definitely have two angles and one side. In fact, we have two angles and two sides, and that's more than we even need. So because we have the two angles and a non-included side, there's two non-included sides, so it doesn't matter which one you go off of, this way or that way. We're going to use the AAS congruence theorem. So we cannot use side, side, and one angle. We can't do that. ASS or SSA, that does not work. So you'd have to use AAS, two angles and the one side. That's what you can use. All right, so that concludes our lesson here on 5.6. And we'll just have one more lesson in Chapter 5 and be done with Chapter 5 soon. I'll see you on the next lesson.